So now it's time to work on the drive shafts. I previously made the rollers and drilled the set screws 90 degrees from each other. Now I need a place for these set screws to sit on the shafting. So I'll mill out a number of flats on the shafting. The flats are about 30 thousandths deep. This depth of the flat will allow me to put ample amount of force when tightening the set screws. And when you put a lot of force on the set screw when tightening, the face is going to want to dig into the metal. I went ahead and tightened one of the set screws, and here you can see the imprint it leaves on the metal. If this imprint was left on the surface of the rod, it would make it extremely difficult to remove the rollers. The reason for that is because it pushes the metal up around the edges. Now jumping over to the mill to show you how I machined the flats. It's a crude setup, but it gets the job done. Because I already machined one of the shafts and properly laid everything out, I could just rest that shaft on top of the one I'm working on now to line everything up. You can make sure everything is level by eye, but I just set an indicator stand to the correct height and sweep it over one of the flats. I'm going to machine the flats to 30 thousandths deep, so to do that I'll start the mill and touch the tool off. And now I'll set up my dial indicator as the readout. When my readout reads 30 thousandths, I know I'm at the correct depth. Now I need to mill the slot 90 degrees from the previously milled area. Again, I'll use the magnetic base as my material stop. And then I'll index the bar by hand and use a square on the table. And now rotating the bar, when the flat is parallel to the square, we know we're 90 degrees. And the last of the machining is to give a spot for this grub screw to bite down on the shafts. So I have the other one set up and this one's done. So this is a pretty easy setup. I'm just going to go about 40 thousandths deep and 2 3/4 long. I'm using the insert just to get through the initial part of the case hardening, and then I'll switch off to a high-speed steel. Everything's now assembled. The complete drivetrain is all brand new. The motor was disassembled and cleaned. I found a new old stock variable speed pulley that was made for this tumbler. The variable speed pulley will allow for the RPMs to be changed on the fly, and that is done with this hand wheel right here. Fire it up. Both the front rollers and the back rollers have power. So now I'll work the variable speed pulley. So when the pulley is at its smallest diameter, the barrels are spinning slower. When it's at its largest diameter, the barrels are spinning faster. So the barrels right now are spinning slow and you can watch them speed up. And then lastly, the belt guards and motor guards go on. Naturally, the barrels have removable doors to keep everything contained. Hope you guys enjoyed. Comment, rate, and subscribe.